So this is the moment at which Clay starts to interweave with the benchmarking initiative for multimedia evaluation, otherwise known as MediaEval. And this is our first joint session. So what are we going to cover? I'm going to give the big picture of MediaEval, our culture, our history, our culture, how we work, our history, where do we come from. And then we have the task organizers for MediaEval this year. So MediaEval has tasks in a way that Clay has labs and Trek and have tracks. So we offered 7 tasks this year, and the organizers will stand up and talk about each of the tasks in turn. We've clustered those basically for understandability into 2 clusters. First of all, tasks that address new frontiers in affect and subjectivity, and second of all, tasks that serve new groups of users. And then we'll close by giving an outlook and telling you some more about the logistics of the joint Clay MediaEval activities. Okay, so we are recording this presentation right now. So we're a multimedia initiative. We try to eat our own dog food, and hopefully it will also be online if the tech goes right. Okay, so let's dive in. This talk is designed so that basically people who are hearing about MediaEval for the first time, and also people who are very intimately acquainted with MediaEval because they spent the last several months working very hard on a task, that both of these groups will get equal interesting information from this talk. And I think I wanted to start out that one of the things that really unites us is the answer to this question, well, why are challenges important? So in the first session today, we heard some answers to this question, but I wanted to underline this answer. So challenges are important because it focuses our effort as computer scientists in the area of algorithm development directly to our end goal, which is making useful systems, satisfying users. Okay, so this is sort of the foundation that binds us together here as a joint Clay MediaEval group. Okay, so how does this unpack in MediaEval? So MediaEval, what we do is we offer shared tasks on multimedia access and retrieval, and a special aspect is that we focus on the human and the social aspects of multimedia. And by this we mean, for example, if we're looking at images, we care about those aspects of images that come into being because the images are taken by humans. So think about the contrast between an image taken by a robot and the social signal and an image taken by human. We also are interested in issues of perception and interpretation. We see a lot of that also going on at NCCIR. That's very cool. This also sets us apart as MediaEval, so the human and the social aspects. Further, we're very problem-focused. Okay, here's the problem, here's the challenge. Now address that with any modality, any source of information at your disposal. So we focus on really exploiting multiple modalities. Okay, so then what we can also see here is that we have a lot of fun playing around with our name, Media Evaluation, MediaEval. Last year, the social dinner was in this city gate in Amsterdam that was built in the Middle Ages. And I'm going to do a quick fly-through of the past workshops, and there you'll see MediaEval coming out in the architecture as well. So here we were in 2010. In 2011, 2012, 2013, 2014, and 2015. 2015, that got a bit modern at the Netherlands Institute for Sound and Vision last year, co-located with ACM Multimedia, and a blank spot for the picture for this year, MediaEval 2017. Okay, so that's a quick run-through of our history. Already this morning we heard Ian say something about our origin story, and so this picture is part of the MediaEval origin story. Does anybody know where this is? Can you guess where this is? Where this picture is? Okay, I can give you a hint. So I took this picture when I was stranded by a storm and there weren't any airplanes going and I was waiting for another airplane. Any And okay, so this is the video clay track at Clay 2009 in Corfu, Greece. How many people were there in Corfu? Okay, how many people got stranded in Corfu? So this gave us a lot of time to think about where we were going as video clay and look forward to what we really wanted to do next. So this is this morning. Ian really told it right. We have a 2008 video clay, and that gave 2009 video clay, and then we move forward, broadened to the 2010, and you see the development over the years of, for example, the affect task and the focus on social multimedia. Okay, so then I have one slide on medieval culture. I crammed a lot on one slide. But I want to tell you about these three aspects here in just a bit more detail. So what makes medieval culture, the way that we work, maybe different, or what were we is particularly important for us? So first of all, we're a bottom-up benchmark. Just practically speaking, it means that the tasks are vetted by our kind of steering committee, which is called the Medieval Community Council. They're vetted, but which tasks actually are offered to the community is determined by the community itself. So we run a community-wide survey, and we try to hit that sweet spot, also mentioned by Ian in his talk this morning, about interest and being ready to be able to do something. And if we feel from the survey that the task is, at that point, then we run it. The tasks are autonomous. Okay, so what I do when I coordinate is I basically, coordinate the telephone conferences and keep things on schedule and give talks like this one. But otherwise, the task organizers that you will see next are very autonomous in their organization. We incubate. Okay, so basically, we're interested in injecting innovation in the multimedia community. So maybe the tasks are probably at the moment that they're like on the pre-takeoff. We try to find them there. And we are not afraid of things that seem impossible to evaluate in the first instance. Another thing we do is we reward risk-taking, okay? So we're a benchmark, so we have a ranked list, we know who got the top score, but we also give something called the Medieval Distinction Mention. And this is a certificate that documents something that teams did that was particularly high potential, out of the box, taking risks, moving forward. And you might not have gotten the top score, but we want to encourage you to do that in order to give us a leap forward in the technology. Finally, Medieval can be considered a collaboration platform, actually. So we put slides, poster, video online, and we are this year also working on ramping up with remote participation. And we spread the workshop beyond a single time and place. So basically, it's a place Medieval is a place to get to know other people. You talk about the task, form groups, go home, write papers, write joint papers. Basically, we encourage just moving from the workshop to getting your work out there on the task in other venues. And this has been particularly successful over the years, so there's not a lot of metrics that you can use to measure Medieval, because we're a way of doing things rather than a strictly structured organization. But to date, the publications arising from Medieval, so Medieval counting the working notes, workshops, conferences, and journals, has given rise to over 700 publications since its inception. And these are the most recent ones, and you see a lot of journals there. For the upkeep of this, I would like to thank our organizational team in the front, Bogdan and Gabi from the University of Polytechnical Bucharest, who really did a great job of keeping us up to date here on which publications are using Medieval medieval data. Okay, some other stats now. This year, we have authors from 24 countries. There are the countries, and just to look over the whole course of our existence, here's our graph. I'm plotting signups, proceedings papers, and workshop participants Okay, so we had a peak year in 2013, which was a lot of fun. It got a little bit difficult to manage, and now we're leveling out to what I hope will be about 100 participants and a nice workshop of 50 people. So this is how we've been developing, and then I would like to also dive deeper into the life cycle, actually, of a particular task, so that you can see with this example how this goes. So let's go back to the picture that I showed you, this image here of Corfu. So we have the medieval placing task, and the goal of that task was to take an image or a video as an input and to predict where in the world that image was taken. Okay, so you basically get that image or video, and you have to make this geolocation prediction. Now, this task was, as I said, medieval is a set of autonomous tasks. Over the years, it was organized, promoted, encouraged by a large group of people. Here are some of them there, just to show you the number of faces that are behind, making one task successful. So basically, they ran from 2010 to 2016. There's a task definition, which I already mentioned, and the focus of the placing task is on, again, this user-captured multimedia. The data and images are from Flickr. The challenges are the weak link between place and pixels. The fact that there's multiple modalities that you can use, including text, and the fact that you have to scale up to an enormous amount of data. So that's the non-functional requirements that sometimes we don't pay enough attention to when we're developing algorithms. We see the social signal here very clearly. The data is unevenly distributed. So this is San Francisco with a heat map showing frequency of people taking pictures. And this is very interesting. It means that even at the end of its lifetime, deep learning was not the solution to this task, right? This is a different kind of an animal here. So, I mean, looking forward, we're interested in the potential of deep learning features, but it wasn't one of those things where we got this magic boost by moving to deep learning. So it's one of the things we learned over the life cycle of 2010 to 2016 there. During that time, the training data, we went from 5K training images at the beginning to 5 million at the end, and by the end, there's, of course, the potential of the full 100 million YFCC corpus to leverage, too. Okay, so then this slide gives the development through the years. So as I mentioned, the training data is increasing. You can see us becoming more and more explorative, adding other evaluation metrics. We stabilized here at about 8% correct with the visual modality and 27% correct with the multimodal modality. Performance leveled off. We learned at the end that Fusion helps because it tiers and added data. We finally figured out how to exploit them. And at this point, the placing task organizer said, hey, this is, we feel like we've saturated in terms of where we're going. Let's use this to spawn a new task. And indeed, this year, a new task was built up on the placing task, and we'll be hearing more about that from Benjamin in just a moment. Okay, so I didn't go through all of this, but if the video works, you'll be able to pause on that frame and go through that in detail. Without further ado, let's move on to the tasks. So the first group of tasks is about serving new user groups, and we'll start out with Benjamin. Okay, so the game rules are everybody has 5 minutes. We have Mohammed Soleimani has kindly agreed to be the moderator, and so yeah. There's the bell if you go over 5 minutes. So here's your 1 minute.
All right. Yeah.
Sign. Okay. So okay, are you going to come and sit here? Okay, and we explained how to click it with that.
Yeah, welcome everyone. I'm Benjamin Lischke. I'm the organizer of the multimedia satellite task. The goal of this task is to basically combine social media, similar to the placing task, together with satellite information. Because it's a new task this year at MediaEval, I want to give you a bit background, how it's organized. So last year at ACM Multimedia, a grand challenge was initiated about combining satellite information and social media. However, it was very open, and there were only 3 submissions. 2 of them here focused on natural disasters. And co-located with the ACM Multimedia, there was also the MediaEval workshop last year, where a similar idea basically was running for the last 7 years, the placing task to establish a link from social media to the top view from above, so geographic information. And basically the participants and organizers decided to initiate a new task, and that's the multimedia satellite task that we present today. And we also decided to focus on one specific problem, and this is natural disasters, since we see this more and more in the recent days. So if you just look at the US, you see the hurricanes, the floodings in Houston, that it's very important, this problem. And the goal of this task is to focus on floodings. So here we basically have 2 subtasks in this MediaEval task. One is about retrieval, given a set of multimedia items, figure out which ones really show direct evidence of a flooding. So you see some images here show water or the sign of flooded, but they don't provide direct evidence of a flooding. The goal is to figure out these images. And the second task is, given a set of satellite images here, basically extract the flooded regions from these images. So it's a segmentation problem. And if you look closer at this problem, it's not so easy. For example, in the top 2 images, you see that if you just compare the 2 images via simple features like color or edge histograms, you don't notice a difference. Also here you have water next to houses, but it's not a flooded region, it's just a canal like in Venice. So you need to extract the high-level concepts of this image. Same for satellite images. There has been a lot of advances in deep learning for segmentation, for example. However, you cannot simply apply this to satellite images since you have a different kind of data. So for example, in this case, we also have the infrared band, so we have more channels. If you take other satellites like Sentinel, you have even more channels, and you cannot just simply apply these. So in order to address these challenges, we released a data set, basically 2 data sets, one for the first task, which is a subset of the YFCC. We had 6,000 Flickr images, annotated for flooding and no flooding, and along with metadata and features. For the second task, we had high-resolution images from Planet Labs, that's a startup in remote sensing, and we covered 7 different locations of flooding events where we extracted these patches which you see here. And as metrics, we use standard metrics like the average precision for the retrieval and intersection of a unit for the segmentation problem. For reproducibility, currently the dataset is on GitHub, so everyone can access it. We also want to make it completely publicly available, but there's still some discussions with Planet Labs. And this year we had 11 teams participating all over the world from our task, so it was very successful. One major insight on this task this year was that multimodal fusion is very important. So just looking at the images itself or just looking at the text itself is often misleading, especially if you take social media content from Twitter or other social media streams. On the other hand, segmentation. So we are able to segment this. However, there's still a lot of potential, and also with respect to generalization to new locations. In a sense. So for the next steps of this task, we currently have 2 options. One is about either covering more disaster types, covering more diversity like hurricanes, landslides, and so on, or going deeper into flooding itself. So for example, considering the temporal dimension, taking this into account, and then making prediction based on this. This is something that we have discussed in this workshop. And we're also looking forward to connect with ImageClear Remote, which has a similar type of remote sensing, and is also important for us. All right. That's it.
This is a Camerata, querying music scores with English noun phrases. So I'm going to talk about this task on the behalf of the lead task organizer, Richard Sutcliffe, who is currently on his way. Basically the goal here, we have scores of music, classical music, and we also have ways of talking about music with natural language. And what this task tries to do is to connect those two, really. So you have a query, which consists of a short noun phrase, and you have a collection, which consists of musical scores in the format of music XML, and you basically want to find the position within that collection and within that particular score that answers the query. So the evaluation is precision and recall. And so here's an example of a document, a piece of music for which we use a score. And so here are some examples of some of the queries. So you're looking for an arpeggiated figure, you're looking for an open G, an open D, and a B, one full step above an open A string. You're looking for the B on the A string and a third of the broken G major chord, or you're looking for the rocking, undulating quality of a 16th century note writing. Okay, so you can see that these kinds of queries are progressing in their difficulty, and another really interesting thing is that the queries are actually built on information needs that come directly from the musicology community. Okay, and for example, a rocking, undulating quality of the 16th note writing, and that's something that I wouldn't be able to do a relevance judgment on. But in the community, there's a lot of people out there that actually need a system that's able to find the sections of scores that are relevant to those documents. Okay, so here we are. In the overview session, what happens is that Richard will actually demonstrate the queries on the piano. You may be seeing the keyboard up there at the registration desk that we'll be using for that, but in the absence of Richard, I'm not able to do that. But so the queries are findable here. And how to address this? Well, you need a combination of music and IR competence in order to do this. So you use named entity and term recognition, you do syntactic parsing, query extraction, and you index the XML files, you do retrieval, and then you do also within the retrieved score passage identification. Over the 4 years that the task has been running, participants have built systems to perform this task. The queries that are on the simple end of the spectrum, we're now able to address those. The complicated ones, those are way out there yet, a lot left to be done. And currently the outlook is to standardize intermediate representations. For example, represent a musical text in JSON. And we refer you to the main presentation, but also I should mention that tomorrow during lunch there's going to be overview posters of all clay labs and all MediaEval tasks, so you can jump in tomorrow at lunch and talk to Richard directly about this task. Okay, so next we move on to the Medico task.
Thank you. Hi, my name is Konstantin. And I'm here to present our first attempt to bring together multimedia and media science. So this task is about image retrieval combined with some kind of medical analysis. So our goal is to help to improve healthcare system, especially in terms of nationwide population screening. Our group working in this medical image analysis for quite a few years. And now we want to involve community into our research process. So as first step in our research and for this task, we have selected image from gastrointestinal tract of human beings. So why this is? My goal here is to bring some evil into MediaEval. So some bad pictures. Why gastrointestinal tract? Because our body is quite complex, and this part of our body can suffer from many different diseases, which are not easy to diagnose compared to, for example, normal cancer or whatever. So, for example, blood disease. So the only one way of doing it right now is to insert something into your body and take some pictures and videos and analyze it, and maybe cut some parts of gastrointestinal tract to stay alive. It's very costly and not pleasant procedure for patients, so our goal is to improve this by introducing automatic systems which can help doctors to analyze the data and can reduce level of discomfort for patients. So how we do it now? So we just take an endoscopes, insert into your tract from both sides, and just inspect what's going on. Modern approach is to use capsular pills, which can capture images, and it goes through the body and takes images. So, and if we can analyze this data and videos automatically, and especially in real time during the real procedures, we can reduce number of misses, which doctors can they always can miss something very small, and yeah. So we want to do it automatically, just point the doctor's attention. We want to make reports and improve the care system. So as first step, we did some research, of course, and we found that there is no data set available in the internet publicly. I mean, there is no data that you can just download it and try to analyze, just look at images if you are interested in this healthcare application. So we started from collecting data together with our partners from Norwegian hospitals. We collected some data, solved some legal issues, and it resulted in two open and publicly available data sets we published at MMSIS this year. So for this task, we have used one of We have used one of our data sets called Quasir. It basically consists of 8,000 images in 8 different classes. First 3 is normal tissue, next one is resection margin after removal of polyps, and last row is just all diseases. So the goal of this task was to distinguish between these classes using very limited training data set, consists only of 500 images per one class, and to be able to process the data sets as the test data set as usual. So the goal is to distinguish between these images. So as metrics, we have used multi-class generalization of Matthews correlation coefficient. It's for future because in future we want to have unbalanced data sets, because for some lesions we can collect more pictures, for some few. So our data set was eventually split into 2 parts, and we also provided some pre-extracted global features to help participants who are not familiar with image analysis to just tackle this problem to see how it works. Ground truth was provided by experienced doctors, so it was like a couple of months of data processing to sort out all this data from unsorted data sets. Yeah. So what is challenging? We don't have much images to use normal image recognition and the classification methods like deep learning and so on. So we want to allow participants here to check how we can proceed with low amount of training data. So variability of object is very high. So our body is very different inside from one human to another, and also disease can look different. So it also was a challenge. And also image quality is different and depending on type of equipment. So we got 5 submissions this year. Surprisingly, results was good. I will report them in my session later. We also found that it's good to use combined approach because it wasn't easy to distinguish between some classes because they have a tiny difference. Yeah, dataset is published online. You can just download it and see. And for the future task, we want to increase number of classes. In this challenge, we want to move towards capsule endoscopes, which have what's quality and Yeah, and I'm done. Thank you very much. So it's interesting task for people who are not in this area. Or if you want to just look at it, just come to me.
So I'm usually more familiar with medical images, but I'm now talking about affect and subjectivity.
This is the clicker right here.
Oh, this one here.
Yeah.
So I will present the Retrieving Diverse Social Images task, which is mainly run by Maya and Bogdan, but both of them couldn't be here today. So I will talk about that. So the objective of the task is to look at both relevance in the query results, but also diversity. So we take images from Flickr, so social media platform, and we evaluate them based on the relevance in the first results, but also the cluster recall, so how many different types of images there were. And we have human judges who cluster the images into different groups. And we have a set of 40,000 images, provide a lot of metadata, so also processed results, so features from convolutional neural networks, descriptors. There's like user credibility, because some people give the same keywords 500 images, and then we know that very likely it's not very credible that all of them have exactly the same metadata. So these kind of things are added and are distributed to the participants. Participants can use that as well. This is just an example. So this is maybe what Flickr would give. So we see, particularly when we look at visual retrieval, often near duplicates are retrieved, and that's usually what we don't want. So in this case, what we want to have is more diversity in the results. So night pictures, different viewing angles, etc. So this is what's being evaluated. The task is run since 2013. So we looked initially at tourism, landmark locations. Now we have it like a wider scenario. We had very focused topics in the beginning. We're now going towards like multiple topics. And we also realized we had diversity annotations also because of limitations of resources of a single person. Now, for the first time, we looked at multiple annotations. We realized people are very subjective, and it's good to have an algorithm that also can adapt to these kind of subjectiveness. So it's maybe not one size fits all. This is about relevance judgment. So, like, first of all, what is relevant in this case? Sometimes some of them might be borderline, and there are also like some mistakes maybe in some of the relevance judgments. Then the clustering, so we can definitely cluster them based on different criteria, and our judges do that. We don't give them very precise criteria, we just let them define different groups, and that's what we then evaluated upon. And so in 2017 we had multiple ground truth annotations. We looked at like how good the systems are for the different annotations. And so user subjectivity, like user intent, is crucial. So there's no one size fits all. We need like algorithms that can adapt to users in this case. And there's definitely a lot more potential for different solutions in this. And I'm finished within the 5 minutes.
So this, I'm not task organizer, but he couldn't come because of his some family problems. I think he's going to arrive tomorrow. I'm going to present on behalf of Emmanuel de Vandera from Lyon, École Centrale de Lyon. So the task is about automatically recognizing the emotional impact that movie has on its viewers. So in this task, the participants are required to get the different data that they have in a video, like audio, visual data, and all sorts of things, and try to train models that they can automatically recognize emotions that are elicited in the audience. And the task had two subtasks. And the emotion has to be recognized over time. So there are windows of 10 seconds that they move, and so they should continuously be able to detect the levels of arousal, meaning the level of activation from calm to excited, or level of balance, unpleasant to unpleasant, over time. So imagine what would be the profile of a movie. Like there are moments that is more exciting. There are moments that the mood of the movie is maybe negative or positive. So this is what we want to, let's say, recognize automatically. There were two subtasks. One was what I explained, finding the profile of arousal and valence, and the second one was about predicting whether a segment in a movie scares people. And this was mainly, the use case was to protect children, so to actually identify the moments in the movie that might elicit fear in children. So the way, I think it's the next slide, yeah. So the way these two subtasks are evaluated, for the first one, it's more like a regression problems because there is a profile or kind of a curve that's being detected. So they use a mean square and correlation. And for the second task, which was about predicting whether the segment scares people, or particularly children, then it's a classification problem. So then they use the precision recall and F1 score. The data set that was used was the Lewis XD data set, which is publicly available. They used, I think it has two parts. They use the part that consists of full movies, because the data set also has another part that is very short segments. But here they use the full movies. It's in total about 7 hours. The movies are Creative Commons licensed, if I'm not wrong. And they also had 7 movies for training and 14 movies for the test this year. And they also provided audio and visual features. The ground truth was created for the arousal and valence part. It was created by crowdsourcing, if I'm not wrong. But it seems that they also use joysticks, so I guess they also did some annotations in-house because they couldn't make the crowd workers use joystick. For fear, they actually used 2 annotators who were actually professionals whose job is to give ratings to videos, to actually tell the broadcasters whether these are, let's say, the ratings that are appropriate for children or not. Let's say the video. So the fear task was actually annotated by professionals. The results, they had 12 teams participating, registering 5 participating in the task. At the end, I think finishing the finish line and submitting. So for valence and arousal, they got better results compared to the last year. But it seems they had problem with the fear one because I think they probably didn't have that many positive segments because there were not that many scary scenes. So it was unbalanced. So the outlook, they want to collect more data and they want to work on the balancing the data set for the fear part. I think I should stop here because the time is up.
Hi, I'm Claire-Hélène Demarty from Technical Art France, and I'm one of the 6 organizers of the Predicting Media Interestingness task. So I think everything is already said in the title. In this task, we try to predict the interestingness of a media content. What I can add is that we are mainly interested in images and videos. And as organizers, we had to tackle, since last year, the beginning of the task, different challenges. The first one being certainly the high subjectivity of the notion, interestingness, plus the fact that we had to define a clear notion, we had to find a clear definition of interestingness and also collect and annotate the data set. But for this, we had the chance that we could rely on a clear and existing use case, industrial use case, which was how to help professionals to illustrate a video-on-demand website by extracting some video frames or video excerpts from a movie. So for example, in that image example, you see the choice that was done for the Captain America movie. So with this use case, the definition that we took was clear. It was a content was considered as interesting if it could make a user, a viewer, feel like he is interested in watching a given movie. So we divided the task into subtasks depending on the content. So for the image subtask, the definition was, given a set of keyframes extracted from a certain movie, can you automatically identify those images that viewers will report to be interesting? And we had a similar definition for the video. So the metric changed. In 2016, we took the mean average precision, and this year we decided to switch to the mean average precision at 10, because we thought it was it was better for the use case that we choose. And as for the data, everything was extracted from Creative Commons license, Hollywood-like movies. And we also provide pre-computed features so that we can help participants from different communities to attend the task. The development set consists is something like 7.4K segments and the same number of keyframes. They were extracted from nearly 80 movie trailers. As for the test set, it's 2.4K segments. And this time they were extracted from 26 movie trailers, but also 4 full-length movie extracts. As for the ground rules, we did it using collaborative annotations with the help of hundreds of annotators from more than 30 countries. And we ended up with a label, interesting or not interesting, for each segment of keyframes. And as you can see, last year's dataset is already publicly available. So as the challenges that you will have to tackle if you want to participate, well, the first thing is certainly the small size of the dataset and the fact that it's highly unbalanced. For example, you can find something like 10% of the samples only that are labeled as interesting. You will have also to cope with the subjectivity of the notion, interestingness, and also with the fact that the data is multimodal and temporal also. So as for the results, in the first year we had low performances of all the systems, and we are proud to announce that this year, although it is still low, we still have a significant increase of the performance, at least for the image subtask. We had also a high number of participating teams for both years, meaning that interestingness is an interesting subject in the research community. And certainly one of the conclusions is that the subjectivity indeed is, well, the notion, sorry, indeed is highly subjective. But we had also the interesting conclusion that image and video interestingness differ. As for the reproducibility, as you have seen, last year dataset is already released, and we plan to release the dataset for this year just after the workshop. And for the future, well, certainly we will try to have new subtasks with different use cases or applications, so that probably we can have bigger datasets, or we can reduce the subjectivity of the notion. And we would like to push forward the affect modeling, which is an insight from this year, from the system, this year's systems, and also temporal modeling, which is also a conclusion that we had last year. Well, I think that's all. Thank you.
Hi, so I'm Dimitri. This is Acoustic Brain's general task. Actually, we are 4 people, 3 of us are here on the conference, so you can meet us later. Our task, let's talk about music for a while, more specifically music genre. So this is how they look like. What's interesting about music genres is that actually they are subjective. So what that means is that what is rock for me is probably pop for you and something else for somebody else. So there is, for certain contexts, communities, and cultures, there are different notions of genres. So, for example, you can have two tracks, okay? And for example, in one music data set, one music database online, some song is called heavy metal, but in another one is called folk rock, and another one is folk metal. Finally, in the fourth one, it is folk metal and metal. So this is more or less consistent, maybe. But for some other tracks, it could be even worse. Let's say something is dub or ambient dub, but at the same time, it can be said it is world fusion or even African. So we want to make a task that will kind of try to explore this, how this fact can be used when building music genre recognition system, and how systems can deal with that in evaluation too. So the goal of the task basically is that we provide features pre-computed from audio. So these features are describing music songs, and then we have a very large data set containing 2 million of recordings, which is annotated by 4 different genre sources. So these sources have different taxonomies. These are genres and their subgenres. And of course, in every source, the meaning of genres is different and of subgenres. And furthermore, what is difficult is that there are hundreds of different subgenres. And finally, well, a song can have many different genre or subgenre labels within the same ground truth, genre source. So which makes this task a multi-label classification task. A bit of context of actually what we are working on a more global scale is part of us. We create a community database that would contain music features extracted from audio for as many music that we can get. And we have a large community that contributes to us. They run our software on their machines to analyze the music collections. And so far, in a few years, we were able to gather 2.7 million of tracks analyzed. And we have many music features for those. And we have links to different music metadata sources online from where we can actually mine general annotations, for example. So this is how we decided to build this task and create our datasets. So we propose to have actually 2 subtasks. Well, the first one is like a conventional system where, let's say, you have to build a system on every genre source separately and evaluate it separately. And typically, general classification is done only on one dataset. So we have then 4 datasets. And the second subtask, we want actually to try to combine all these genre information sources together with the hope that they provide different perspectives, different opinions, and we can maybe make use of that and see what happens, maybe improve the performance of the system. The evaluation is done using, the typical precision recall F-score measures. So this is our first year, so we were very interested to see what will happen, actually. And I think that the main thing that we found is that the task is really challenging. What that means is that, there is a lot of room for improvement. Many systems that they were actually performing close to our baselines, while a few really advanced, which is nice. We had 5 participants this year. I think one of the most important things that we found is that analyzing subgenres is much more difficult problem than genres. They are very kind of fine, narrow, and there are more of them. And I think that for the future, we are planning to kind of develop better systems focused on subgenres. Furthermore, this year, unfortunately, not all participants actually took advantage of that. We have relations between genres and subgenres. And these hierarchies that could be explored a bit more. And furthermore, like the idea of combining different ground truths for now doesn't lead to significantly better results, although we saw some small improvements. And actually having our data now, we already can start doing some other research, like between musicology and music information retrieval. For example, we can ask a question: is there some music that is just inherently difficult to annotate by genres? Probably there is, so we can kind of analyze the submissions of our participants and check what are the difficult areas, check the metadata for that music, and see what it is. Probably there are some particular genres that are difficult. And in fact, the final goal of this for us as creators of Acoustic Brains, the database that we try to build, is actually to be able to build a real system that will be able to predict genre or subgenre labels for all recordings in our large data set containing like 2.7 million of tracks currently. So if you have more interest in this topic, please come to see us. 3 of us are here on the conference. We'll have a poster. And yeah, so thanks a lot. Have a nice day.
Yeah, okay. Okay, I'm going to do just a couple minutes of wrap up on moving forward and letting you know what the logistics are for the rest of the Medieval Clay joint program. Putting together all the things that we strive to do, the benchmarkers that we strive to be, we come up with the ABCs on innovating for challenges. And so I just wanted to share this with you as a sort of a wrap-up about what medieval culture is all about. So basically, and it becomes a bit poetic too. So we analyze infinitely, we benchmark infallibly, we collaborate infectiously, we dare informedly, we explain informally, and we fail informatively. I must say, I was very influenced in Clay back in 2009, Corfu, when Carol Peters stood up and started reciting poetry. And somehow poetry also often goes through my mind with benchmarking. So those are kind of our goals. You can see it as a list, or you can see it as a bit of a poem there. So the ABCs of challenges. These are the things that we strive each year to do anew, and we're very happy as Medieval to be here at Clay to be doing them together with you too. So just a few words on logistics. So what Medieval today? Okay, so there's going to be lunch. We're going to have some poster boasters for the Clay short posters. And then we're going to go into lunch. So during lunch, the Medieval participants who have just arrived, you should seek out your task organizers who you've seen, or the person that gave the presentation, and then you can start connecting up with them and connecting with each other. So everybody should enjoy the posters. Then at 13:45, in parallel to the Clay program, so Medieval people can also go to the Clay program. In particular, I think some are going to go to Life Clay. I know that already. We have 2 Medieval activities. So these are the multimedia mixer and the planning session on Interestingness. So if you did the Interestingness task, please go to this planning session, which will be led by Clara Len. And other Medieval people go to the Medieval mixer, which will be led by Mohammed and Matthias. And there you'll get to know the other Medieval people and talk about your task and things moving forward. Okay, so this is going to be at the ADAPT Center. Okay, so if you remember, ADAPT is one of our Clay sponsors here, and their center is over in O'Reilly. So in order to get there, we're going to meet out in front of the Arts Building. We have this particular shield. You can look for somebody holding this, and that will take you over to the ADAPT Center. And if you miss that particular launch point, just go to the desk and we'll connect with somebody to get you, because ADAPT, you need to be able to get through the security. So we'll figure out how to get you in if you miss the 13:45 meeting point. And then, so we're back here for coffee. And then at 16:15, again, Medieval people can either go into Clay, or you're in the Medieval planning sessions. Again, we'll meet at the point with the sign and go together to the DAP Center, so just out front of the Arts Building here. And those planning sessions are with Dimitri and Benjamin for the multimedia satellite task and the acoustic brains task. Okay, and then tonight we're looking very much forward to the joint gala dinner at 8 p.m. To see everybody there. And then just a quick word about tomorrow. Okay, so tomorrow everything is going to be in the Long Room Hub. So at the desk, there's this sheet that you can pick up to see as a clay person all the medieval activities you could potentially take advantage of. And they're all in the Long Room Hub. I have just a small typo there. So the Long Room Hub is the building right over there, the new building. So at 9 o'clock we kick off with the satellite task. At 11:15 we'll have the predicting media interestingness task. And then we'll come back together for a joint session here, which will be very interesting. So please be ready to comment on the tasks you heard about today on Clay Labs. During lunch, we'll be looking at overview posters, and we'll be asking you to put your comments on them with sticky notes. So we're looking for what you find interesting, what you find important, what you find attractive, what you find not attractive. So just be thinking about what you heard today and be ready to give your input, which will then be discussed in two different panels moderated by Mohammed and myself. So it should be a very interesting afternoon of joint sessions tomorrow. At 16:30 is the Clay closing, and then after that you can go back over to the Long Room Hub if you haven't had enough benchmarking yet, and take advantage of the medical multimedia task that will be there. Okay, so that ends the opening presentation of MediaEval. Thank you very much to the task organizers. Really, it is the work of our task organizers, task organization teams that make MediaEval possible. So, thank them.